Hey, today I'm going to be talking about the TZ ObjectScript time zone conversion library that I have been working on. What I have found is that ObjectScript allows you to easily convert your system timestamps from your system local time to UTC and back and forth, but it's harder to convert timestamps between arbitrary time zones. So that's what this library was created to do. It was created to allow you to easily change timestamps from one time zone to another in ObjectScript. So if you go to OpenExchange and you search for TZ, you should be able to find this TZ library pretty easily. From there, on this page, there's a lot of information about the problem we're trying to solve. Some examples of how to use it in ObjectScript and various other ways, installation instructions, things of that nature. So it's pretty easy to install. If you have a ZPM installed, then you would just go to ZPM and you would type install TZ. That should install it pretty quickly and easily. If you don't have that, what you can do is you can import the class directly by downloading an export from the GitHub repository, and then go into your system operation classes page and performing an import on that page to import this XML file. So that's what we're going to do today in this video. So I'm going to go up to the top up here and go to the GitHub repository. Then from there, I'm going to go to exports and download tz.export.xml. And this should always be the most recent version. You can see here we have older version, well, the various versions that have been released. Currently we're on 1.0.0, so that's the same as this tz.export.xml. So I'm going to click on that. I'm going to download it. This is the second time I've downloaded it here. So then from there, we can go to our Iris install. This is Iris for health. Go to System Explorer, Classes. Notice I've filtered down here for all the TZ star.classes, and currently there are none. So we will now go to this import button, go to my local machine, browse to the file I just downloaded. Then make sure compile is checked, hit next. You should have 5 classes that it will import, and those should import or load successfully. After you've done that, now when you come back to this classes page, you should see those 5 classes here. You can click on each of these to get instructions on the documentation on how to use this stuff, but honestly, your best bet will probably be to go to the package page here and to read the instructions here and the links provided there for instructions on how to use it. So now that we've got it installed, what we want to do is verify our installation. So I'm going to copy this command here. Oh, notice also when I did the import, I imported to the user namespace. This can be any namespace that you want to install this in. So now we'll go to our terminal. I'm already in as root, so I'm going to switch to Iris owner and start an Iris terminal. There we go. All right, so now I should be able to insert this command to test the install. Unfortunately, 18 tests were successful, but there were 98 errors. And the reason for this is I'm using a base Iris for Health Docker install that does not have the operating system's TZ data package installed. So this TZ ObjectScript library relies upon embedded Python, which also relies upon your operating system's TZ data package to be installed. The TZ data package typically includes a database of all the different time zones across the world. So the problem here is that package is not installed, so it's not able to convert between the various time zones. So what I'm going to do is exit out, halt out of the Iris terminal, go back to root, do an app update, and then from there do an apt install TZ data. If you're on Red Hat or a Red Hat variant, you could probably use a yum install TZ data or some other variant of that nature. All right, so it has installed TZ data for me. Also, if this is the first time that you've installed TZ data, it may prompt you for what time zone. In this case, it knows that I want to use America, New York, and so it's going to keep that one for me. So now we've got that installed. I can go back to Iris Owner, and I can start an Iris terminal. I can run the test command again, and now all 116 tests were successful. So now that we've verified our installation, let me show you what it would look like, how you would use this in a data transformation for, say an HL7 message. So I have an example data transformation here. I'm copying several segments here. So in this example DTL, what we are going to do in these demonstrations here, we're going to manipulate MSH7, the date and time of the message, and show you how to use the TZ library to do those manipulations. So I'm going to copy MSH7 to MSH7 here. I'm going to compile it. And before I make any changes to use the library, I'm going to go and show you the test message. So I'll pull this test message off of Wikipedia, and it has a timestamp here with an offset of -500. So what we want to do is we want to convert this timestamp from -500, which I believe would be a central time zone, and at this time of year, this would be a central time zone timestamp. So we want to convert it, let's say, to New York, which is Eastern time zone. So we'll close this here. We've already copied MSH7 to MSH7 here. So now I can just come to our value, hit the button here to open up the functions. And when you install the TZ library, it installs these 3 ENS functions for you to use. So these are the 3 that you would use to access the TZ functions from in a data transform or a routing rule or something of that nature. So we're going to start with TZ, and we're going to take our source timestamp, and we want to convert it to the America, New York time zone. In this case, since the input has an offset, we don't have to specify a source time zone and a target or desired time zone. We can only specify our desired time zone in this field, and it will convert it to that time zone. Compile. Test. All right, so 9:01:31 from a central time zone to New York or Eastern time zone should come out as 10:01:31. And you look, and it does 10:01:31 with a -400 offset. All right, so that's that example from converting from one offset to another. Let's say we wanted to convert this to another time zone, maybe not America, New York, maybe we want to change it to Los Angeles. So we can come in here, edit this, change it to Los Angeles. right, so 9:01:31 in Central Time. When you convert it to Pacific, that would be 2 hours ahead of here, so that should be 11:01:31. I'm sorry, not 11. It's behind, so it would be backwards 2 hours. So that would be 7:01:31, and that's what you see here, 7:01:31 with a minus 700. So that you can see, it's converting it to the various time zones as we put them in. Now this time, let's keep it in Los Angeles time zone, but let's remove this offset. So to remove the offset, instead of using the TZ function, which keeps the current format of the timestamp. So if the timestamp has an offset, the input timestamp has an offset, the output timestamp would have an offset as well. If we want to switch that so that it uses only the local, so it removes the offset, then we will take our source, we'll add the TZ local function, and then here we put our desired time zone. So America, let's go back to Los Angeles. So now this should show us, should convert it from 9:01:31 to 7:01:31 without an offset. There you go, 7:01:31, no offset. We can also go the other way, so we can take this offset off. Actually, let me go change. So now that we're taking the offset off, let's say we have to tell it now that what time zone this is in. Since there is no offset, the library needs to know what time zone this timestamp is in. So let's close this and go back to our TZ local. So when we need to tell it the source time zone, we put the source time zone here. We'll say it was Chicago. And this is the time zone we will convert it to, which we'll say we'll keep it in Los Angeles. All right, so 9:01:31 from Chicago or Central Time, converted to Los Angeles time, which would be Pacific. That should be 7:01:31 still, and it is with no offset. So the key takeaway here is if the input does not have an offset, you must provide it as an argument to the TZ library. All right, now same thing, we have a Chicago time zone with no offset, a local time. Let's say we want to convert to Los Angeles, but we want to add an offset now. So to do that, we would choose our function. And this time, instead of TZ local, we would choose TZ offset. Our source time zone, since it's a local without an offset, we have to provide a source time zone. So that would be America, Chicago. And then what the desired time zone is what we want to convert it to. America, Los Angeles. Compile. All right, again, 09:01:31 in Chicago, converted to Los Angeles, should be 07:01:31 with an offset. And it is 07:01:31 with a minus 700 offset. And then the final demonstration, let's assume for some reason you wanted to change the format of your date, in this case MSH7. Most of these TZ functions should have oh, not this one. You would use the tz function. Here we go. The tz function has a desired format option. So we'll still be converting it from Chicago to Los Angeles, but the desired format here, let's say we can use any of the formatters that's talked about in the documentation, but you can say something like year dash month day hour minute second, and let's put the offset %z as well. Compile that. So now it should take this from Chicago, convert it to Los Angeles. So we should get 070131, but it should be, instead of an HL7 format, it should be formatted with slashes and colons and an offset. And it is 2006 0529 07 01 31 minus 700. So that's how I would expect you to use this library in most day-to-day applications. If you need to do something more complex than what I've shown today, then most likely you can find the information you need on the main project page on the documentation that's provided here. You can go through, there's some examples, how to use it from ObjectScript instead of from a TTL. Like we said, our installation and verification steps. It talks about some of the supported time zones, all of the different formats that you can use if you need to reformat the date times, all the different formats that it recognizes by default when you use those tz local, and tz offset methods. And then it also links to documentation about the specific classes. So the TZ-ENS documentation linked here is for those three TZ local, and TZ offset functions that we used in the DTL. It also provides documentation for the tz.hl7 class and the tz.tz class. You have examples, input formats, things, argument, descriptions, things of that nature. So anyway, thank you for joining me today. I hope that you found this library useful. If you have any questions or any issues, please review the library, post a review, and I will try to answer any questions. Thank you.
Hello, I'm Yuri Marx. I'm from Brazil. I'm a system architect, and I created Iris Global VSCode editor for the context. So this app is a VSCode extension to manage your Iris globals, edit, create, delete your globals. So you can add a new global here, zzz, tests, enter. I created the new global. I will refresh to see my new global, zzz. I can delete this global deleted. So I will refresh again, and zzz, now not here, okay? I can filter my globals. Test. I will filter. Only test globals will appear to you. Okay. So I can edit use Yammer too. Create all existent subscripts here in a Yammer file. I will add more two subscripts. 3, 1, 3, 2, hello, iris, and I will save. When I save the file, the global content will be written to in Iris, save it in Iris. Okay, the global save it. If I go to the Iris console, and the connection will be here. Connection settings. Okay, in this part, I will go to management portal. And I will see the globals. Uh, test, test. Hello Iris. Hello Iris. Okay. This app was created using the API for create extensions, and to create an extension, you go to the package JSON, and you have an Explorer view. This is the Explorer view with these commands: add, delete, edit, edit text for Yammer editor, refresh, filter, all commands that I show to you here declared in package JSON. Okay, and the properties, the configuration properties for this new extension, and the implementation will be in extension TS. In extension TS, I register my commands for VSCode. Register a provider that will be the implementation, and all the commands are registered here. And I register a save global in Yammer file when I save a text document. So when I go to my provide, I have all the implementation here. Okay, adds, edits, deletes. Okay, all the implementation here. So this is my extension. Thank you.
Hi guys, I'm here to present you our application to the Bringing Ideas to Reality contest, which is an implementation for this idea from Ron Sweeney, an idea about a way to manage secrets in Iris, something similar to AWS Pyramid Stores, Kubernetes secrets, and the credentials feature in Assembly. So we come up with this idea and create a project called VaultLink, which is basically a wrapper to access secret storage into Key Vault platforms. In our case, we are using the HashiCorp Vault Community Edition um, store for secret storage. Um, yep. So I will walk through the demonstration. Of course, you can install just the application into your Iris instance by using IPM, issuing this command. But in this video, I would like to walk through some additional steps to up local HashiCorp Vault instance and showing how to use the application. So first, we have to clone this repository. So let's do that. Okay, now we are in the directory. All right. Next step is set up the hash vault instance. For this project, we provide a Docker Compose file with basic configurations for demonstration purpose only, not intent for production. So let's enter into the HashiCorp Vault uh, directory and start its container. So okay, now we have our HashiCorp container. You can up and running. You can inspect it by issuing docker compose logs command. And okay, we have our vault server started. Let's come back here. Now we have to enter into the container and initialize the server. So let's do that. Let's take a couple of seconds. Okay, now we have our unsealed keys in order to unseal the vault and the initial root token in order to log in into the vault. So let's enter into the web user interface. Now it are prompting us to provide 3 unsealed keys. We have to choose 3 of those 5 ones. So let's take another one. And we have provided just more one. Okay, our vault is unsealed now, so now we have to use the provided token to log into it. And that is it. We are into the HashiCorp vault. Let's come back to the instructions. Okay, here's just presenting we have just done. Okay, now we have to exit the container and start the Iris setup. The first setup we need is to configure these 2 environment variables in order to provide the application the URL for the HashiCorp API and the token to authenticate to the API. So let's copy that and execute. We have also to copy again the token. Okay, now we have our environment variables set up, and now we can build our iris image here. This will take a couple of minutes. I will pause the video and come back with it done. Okay, the container has been created and running. Now we can continue the tutorial. Now let's check how to use the application. First, I have to access the Iris container. So let's do that. Okay, we are now in the Iris app namespace. Now let's create a generic key value store into the HashiCorp vault. We can check the new vault, the new in the secret engines section. So now I have my key store. No secrets yet. It's the next step. We are going to create a new secret. So let's copy that and run it. As you can see, a new secret was created. We can also check in the user interface. Let's check the secrets again. My key store, my secret. Now we have our secret. We can check the value for password and username. Um, the next step is to read the secret from the Iris application. For this we use this one. This is another command, get secret. And as you can see, we have access our secret, password, and username. Uh, and as we can you can see, we return the value into a dynamic object, so we can access using JSON notation into Iris into your Iris application. So like we can access the username and the password separately using a nice JSON syntax. So that's why you can use secret stored in HashiCorp into your application without have to hard code or then into your code or using environment variable and so on. Hope you enjoyed, and thanks for watching.